Welcome back. We're going to go ahead and continue working on the MPLS lab topology. We're still working on the MPLS provider backbone. Zoom in here again. Still going to be working on PE1 and PE2. So in our previous videos we've gone ahead and set up the base configuration, the IP addressing, and then we've set up OSPF for the backbone. So the next part is actually to set up label forwarding and VPNv4 BGP to actually set up MPLS end-to-end between the two provider routers. So let's go to the detailed network topology. Zoom in here. Okay, we're going to continue here, PE1 and PE2, and we're going to be setting up IBGP VPNv4. The autonomous system number, or ASN, is 64512. That's the ASN assigned to the backbone here. So let's go ahead and bring up the command line again. So here we are, show IPOS neighbor. See that we still got our neighbors. And our configuration, like I said, is just the base configuration that we did with the IP addressing, and then the OSPF configuration. So step one, we're going to go ahead and configure label switching here on the interface and forwarding the MPLS packets. So start out with MPLS IP router ID. We're going to set that to the loopback 0 and force that. So that just basically when we make an LDP adjacency between the two routers, we're going to go ahead and use loopback 0 as the router ID. Okay, so the MPLS IP command is a global command. We still need to do it at an interface level, but this turns on globally the MPLS forwarding. I will turn on the label protocol. We'll set that to LDP. Make it require a password. And then we'll go ahead and put a password in. So now, like I said, we did MPLS IP to forward MPLS packets globally. We need to do that at the interface level. So again, if we go back to the diagram here, we'll see we need to set that up on gig 00 and gig 000. Okay, that's fairly straightforward. We're going to do a couple of commands under the routing process and under OSPF. And these are good commands to do. They're not required, but this is something that's very good on an MPLS network. Okay, so MPLS LDP sync, what that does is that basically syncs the routing with LDP, and that's really important because what happens is we need to have what we call a label switch pass. So we need to be able to make sure that labels are being passed when we forward traffic over the gig links. If we don't do that, then the traffic from the customers just won't go through it or just get dropped, and we will actually black hole traffic. So synchronization makes sure that, especially when a router comes up or after a link's gone down, it makes sure that LDP is working before the IGP will actually form, will allow the adjacency to start passing traffic. The second command, MPLS LDP auto config, is similar, but what it does is it actually can make sure that MPLS IP is turned on any OSPF interface that would be routing packets. If it's not, once again, we would have a path that's not label switched, and then customer traffic would get black holed. So those commands are very useful. So we've got PE1 set now. Let's go ahead and go over to PE2. We'll put in the same thing. Enable a packet forwarding, MPLS packet forwarding at the global level. Set LDP as the label protocol. Require a password. then set the password. All right, we're going to go ahead and turn it on the interfaces. Okay, so let's go ahead and go back to the diagram and just verify what we've done here. So this is back to PE1 and PE2. Down here, you'll see down here in the legend, you remember from the initial video here that we formed the LDP adjacency. This is the little blue dot that represents LDP across this link here. So we now have LDP between here and here. We have OSPF between here and here. So now we're going to be ready soon for IP BGP VPNv4. But before we do that, let's go ahead and go back and just run some verification commands on LDP. Save our changes here. And then let's verify that we're able to form a label adjacency with the LDP. Okay, and we see that we have. See our neighbor here. So we're on PE2, so our neighbor is 10.0.0.1. That's the loopback on the other side. It is a TCP connection using port 646. And you'll see that the sources here, the physical interfaces that this can go over is gig 00 and gig 000. So that's that there is working. You can see those other interfaces that we had on there. They are bound to this LDP identity. Alright, so we can look here and see the same configuration on the other router. So again, we see that it is up. We see that we've got both interfaces are working, and it's bound to these other addresses on the other neighbor. Now additionally, we can make sure that our password is working correctly. We know that it is because we have an adjacency, but we can get a little more detail on that through the show MPLS LDP neighbor password. Okay, so you can see that the password is required, fallback, and it's in use. Okay, now that we've got MPLS LDP set up, we know we've got good LDP adjacency. We're going to go ahead and set up BGP, VPNv4. And that's what will be used to go ahead and basically communicate all the routing back and forth between the different provider edge routers. So let's go ahead and configure that now. Whenever I configure BGP, I always turn on IPBGP-community new-format. It's funny, it's actually not very new, but that's what the command is. It's basically, it now adheres to RFC 1997. It's the old way that Cisco did it had a long 32-bit number. It was kind of hard to understand and follow, so they followed the RFC, and the community now is in the form of like ASN colon and then a value, which makes it much easier to read. So it is just for apparently for reading. It's not anything changed in the routing update, but that's something that makes, if you're using communities, it makes it a lot easier. Okay, so we're going to go ahead and set up BGP using an ASN of 64512. That is a private ASN, the very first one in the private range. We'll set the BGP router ID to the loopback 10.0.0.1. Okay, we want to log the neighbor changes. And turn off auto summary. It's by default on all newer code, it's off, but just enter it in. I got used to doing it over the years. Okay, the no BGP default IPv4 unicast, what that does is that just, as we're setting up our MPLS backbone, there's really no need for IPv4 between the provider edge routers. Now we will use that from the PE to the CE down to the customer. However, that's in a different a different address family, we'll be doing that. And this, what we're doing here for the MPLS across the backbone, we're just going to be using VPNv4, so we don't want the additional overhead of an IPv4 address family on top of the VPNv4. So we'll go ahead and start building our neighbor. So our neighbor is 10.0.0.2, and we're going to have a remote AS of 64512. So this is an IBGP session. That's what we do for the MPLS backbone. And I'm going to go ahead and set the password here. And this is important to make sure the update source is set to loopback 0. That's important for the way that the labels get popped. If you don't use the loopback, the labels get popped a little bit too early through the penultimate hot popping PHP, and then that can actually cause trouble with some of the connectivity. So we specify the update source being loopback 0. We're going to go ahead and just adjust the timer slightly to 5-second hellos and 20-second hold. Now we go into the address family VPNv4. There's a number of different address families in BGP. But what we want here is we just want to have the VPNv4. That's the current one we're going to be working on. And we've already specified a neighbor globally, so we're going to go ahead and activate it. And in addition to that, we are going to send both the standard and the extended communities. So go ahead and save our changes. Go over to router 2. And now we got to do the same thing over here. Turn on the new format. And set our router ID again on, we're on PE2, so our loopback here is 10.0.0.2. Go back in the address family VPNv4. We'll activate the neighbor. And we're going to send both the communities. Alright, so we'll go ahead and see if we've got an adjacency here. Sometimes the BGP adjacencies take a little bit to come up, maybe 20 seconds or so. Let's see what we got. Show IP BGP VPNv4 summary. Show IP BGP VPNv4 all summary. And we'll see we've actually got a neighbor now. So you can see that we've got a neighbor 10.0.0.1. His AS is 64512, and he's been up for about 30 seconds when we looked at it. So there are no routes here. That's not what we're learning. We just basically got a VPNv4 set up, and that's how we'll send our customer routes. So let's go over to PE1. See that it's up and it's looking good. And that's it for BGP VPNv4. Before we end this video, there's one more thing that I like to do, and that's to add in a little bit of security here. So when we are start to peer with the customer networks, we don't want the customers to be able to access our equipment at the provider side. So what we're going to do is just go ahead and put some security against the VTY line and protect that. Okay, so we're making an access list here. This is a standard access list based on the source IP. So access list 10, this is our management network, 10.100.0.0/24. Again, this 000255 is a wildcard mask. That is our management network, and then we'll go ahead and apply that to our VTY line. Now, when we do this, we have the option of just applying it like this, and then that'll apply it so it applies to the global VRF. But in here, we could also grant access to the VRFs also, but we wouldn't really want to do that in this case. So what we're doing is we're just going to go ahead and apply it without the VRF also command, and that will now protect our router so that other people from the customer side can't get to it, and only from our global routing instance we'll be able to get to it from the management network. So let's go ahead and apply that same config on PE2. And apply that to the VTY lines over here also. And now you can see here that our line VTY, we got our access class 10 in, and again, like in our base config here, we've gone ahead and we've shut down the line VTYs 5 through 15. So that's it for this video. Our next video, we'll go ahead and start configuring the customer networks.